From the dawn of humanity, the sun has captivated our imagination, inspiring countless myths and legends across cultures. It has been a source of wonder, fear, and worship, shaping the very fabric of our civilizations. Ancient civilizations recognized its importance as the lifeblood of our planet, building grand temples and monuments in its honor. Today we understand its true nature as a star, a giant ball of burning gas that dictates the rhythm of our solar system, providing light and warmth. The sun's immense gravity holds planets in orbit, ensuring the stability of our cosmic neighborhood. Its energy fuels life on Earth, driving the process of photosynthesis in plants and powering our modern technologies through solar energy. It's the most important celestial object in our sky, a constant presence that influences every aspect of our lives. The sun lies at the heart of our solar system, a central figure around which everything revolves. It's about 149.6 million kilometers from Earth, a distance we call an astronomical unit, or AU, a fundamental measure in astronomy. This massive star is not static. It is a dynamic entity with constant surface activity. It rotates on its axis, completing a full rotation in about 27 days, a fascinating aspect of its behavior. Interestingly, the sun's equator rotates faster than its poles, a phenomenon known as differential rotation. This differential rotation plays a significant role in its dynamic magnetic field, influencing solar activity and space weather. The sun's influence on Earth is undeniable, affecting everything from our climate to our daily weather patterns. It dictates our seasons, drives our weather patterns, and provides the energy necessary for all life, making it indispensable to our existence. Understanding the sun is crucial, not just for scientific knowledge, but for appreciating our place in the universe and ensuring our survival. It's a reminder that we are part of something much grander than ourselves, a vast cosmos where the sun is just one of billions of stars. The sun is like a giant onion, with layers of different temperatures and densities, each playing a crucial role in its overall structure and function. At the sun's core, temperatures reach a scorching 15 million degrees Celsius. This is where the magic begins. This extreme heat fuels nuclear fusion, the process that powers the sun. Hydrogen atoms fuse to form helium, releasing immense energy. Surrounding the core is the radiative zone. Here, energy generated in the core slowly makes its way outwards in the form of radiation, taking thousands of years to pass through. Above the radiative zone lies the convective zone, where the dynamics change significantly. In this turbulent layer, hot plasma rises to the surface, cools and sinks back down, creating a continuous cycle. This continuous churning creates a convection current, much like boiling water in a pot, driving the sun's dynamic behavior. The visible surface of the sun is called the photosphere. It's the layer that emits the light we see. This is the layer we see from Earth, radiating light and heat, essential for life on our planet. Finally, we reach the sun's atmosphere, which consists of several layers. The lower atmosphere, the chromosphere, is a thin layer visible during solar eclipses, glowing with a reddish hue. Above it lies the corona, the sun's outermost atmosphere, extending millions of kilometers into space. The corona is much hotter than the photosphere, reaching millions of degrees Celsius, a phenomenon that puzzles scientists. Its high temperature is still a mystery that scientists are actively trying to solve using advanced technology and space missions. The sun's immense energy output comes from nuclear fusion happening at its core. Fusion is the process of combining lighter atomic nuclei to form heavier ones, releasing tremendous energy in the process. In the sun's core, hydrogen atoms are fused into helium under immense pressure and temperature. This reaction releases a staggering amount of energy, equivalent to billions of atomic bombs exploding every second. The energy produced in the core then takes millions of years to reach the surface. It travels in the form of photons, particles of light. Once these photons reach the photosphere, they are released into space as sunlight. This sunlight takes about 8 minutes to reach Earth, providing us with light and warmth. The sun's nuclear fusion is a delicate balancing act. The outward pressure from the energy released constantly pushes against the inward force of gravity. This balance, known as hydrostatic equilibrium, keeps the Sun from collapsing under its own weight. It's a testament to the incredible forces at play within our star. Life on Earth, in all its diversity and complexity, is entirely dependent on the Sun. The Sun's energy drives photosynthesis, the process by which plants, algae, and some bacteria convert light into chemical energy. Through photosynthesis, these organisms produce oxygen and glucose, essential building blocks for life. This process forms the foundation of most food chains on Earth. The Sun's energy also drives Earth's weather patterns. The uneven heating of Earth's surface creates temperature differences, driving atmospheric circulation and ocean currents. This constant movement of air and water distributes heat around the globe, shaping our climate and weather systems. From gentle breezes to powerful hurricanes, the Sun's influence is felt everywhere. The Sun's ultraviolet radiation, while harmful in excess, is also essential for life. It helps our bodies produce vitamin D, crucial for bone health and immune function. The Sun's warmth dictates our seasons, influencing plant growth, animal behavior, and even human culture. Our lives are intricately linked to the rhythms of our nearest star. Section 5, Stellar Evolution, the Sun's journey through time. Like all stars, the Sun has a life cycle. It is a dynamic and ever-changing entity, constantly evolving over billions of years. It was born from a collapsing cloud of gas and dust about 4.6 billion years ago. This process, known as stellar formation, is the beginning of every star's journey. The Sun is currently in its main sequence phase, where it will spend billions of years steadily fusing hydrogen into helium. This phase is marked by stability and a consistent output of energy. However, this stability won't last forever. The Sun, like all stars, will eventually run out of its primary fuel. In about 5 billion years, the Sun will exhaust the hydrogen fuel in its core. This marks the beginning of a dramatic transformation. As a result, the core will contract and heat up, causing the outer layers to expand dramatically. This expansion will turn the Sun into a much larger and more luminous star. The Sun will transform into a red giant, engulfing the orbits of Mercury, Venus, and possibly even Earth. This phase is both awe-inspiring and catastrophic. This phase marks the beginning of the Sun's decline. The outer layers will be shed, creating a beautiful planetary nebula. Eventually, the Sun will shed its outer layers, leaving behind a hot, dense core known as a white dwarf. This remnant will be incredibly dense and hot. This stellar remnant will slowly cool over billions of years, eventually fading into a black dwarf. This final phase is a quiet end to a once vibrant star. The Sun's journey through time reminds us that even the most massive and seemingly eternal objects are subject to change and decay. It is a humbling reminder of the transient nature of the universe. Section 6. The Sun's temperament, solar activity, and its effects. The Sun is not a quiet, unchanging star. It exhibits dynamic activity driven by its powerful magnetic field. Sunspots, dark patches on the Sun's surface, are cooler regions caused by intense magnetic activity. Solar flares are sudden bursts of energy, releasing radiation across the electromagnetic spectrum. Coronal mass ejections, or CMEs, are massive eruptions of plasma and magnetic field from the Sun's corona. These events can hurl billions of tons of material into space at millions of kilometers per hour. When directed towards Earth, CMEs can interact with our planet's magnetic field, causing geomagnetic storms. Geomagnetic storms can disrupt radio communications, GPS systems, and even power grids. They can also trigger stunning auroras, colorful displays of light in the sky near Earth's poles. Understanding and predicting solar activity is crucial for protecting our technology and infrastructure from its potential impacts. Section 7. Unveiling the Sun's secrets. Solar missions. To unravel the Sun's mysteries, scientists have launched numerous missions to study it up close. The Parker Solar Probe, launched in 2018, is on a daring mission to touch the Sun. It will fly closer to the Sun than any spacecraft before, braving intense heat and radiation to unlock the secrets of the solar corona and solar wind. Other missions, like the Solar Dynamics Observatory, or SDO, continuously monitor the Sun from Earth's orbit. SDO provides high-resolution images of the Sun in multiple wavelengths, helping scientists study solar activity and its impacts on Earth. These missions are providing unprecedented insights into the workings of our nearest star. By studying the Sun, we gain a deeper understanding of the universe around us. The Sun serves as a natural laboratory for studying stellar astrophysics. It helps us comprehend the processes that drive stars and their influence on planetary systems throughout the cosmos. Section 8. Fun facts about our nearest star. Here are some intriguing facts about the Sun. If the Sun were the size of a basketball, Earth would be the size of a pinhead, and the distance between them would be about 25 meters. The Sun contains 99.86% of the total mass of our solar system. The light from the Sun is actually a mixture of all colors, which appears white to our eyes. The Sun's magnetic field is about twice as strong as Earth's magnetic field. The Sun generates more energy in 1 second than humanity has consumed in its entire history. Section 9. A star to appreciate. The Sun, our life-giving star, is a constant presence in our lives. It is easy to take it for granted, but we should never forget its importance. The Sun provides the energy for life, drives our weather, and shapes our world in countless ways. Its study continues to unravel the secrets of the universe. So, the next time you feel the warmth of the Sun on your skin, take a moment to appreciate its power and splendor. It is a star worthy of our awe and respect.